Hello, good afternoon. My name is Leonardo Trecoluna, and today I'm presenting my evidence to where I design state feedback in discrete time. So first of all, we have to define what discrete time states model is, and basically it is a system that provides the same type of linear difference relations between the inputs and the outputs as the linear ARX model, but they are rearranged in such that there is only one delay in the expression. An important thing to say about discrete time state space models is that they have a big difference between the continuous time state space. In continuous time, we have infinite measurements, in short words, because we have all the measurements at all times. And as we know in reality, that can't be possible because the sensors we have take measurements at specific times that are definitely not infinite. So let's say we have a sensor that gets a measurement every 1 second. So we will have then a value for that sensor every second, not at all times. So in order to get a controller that can deal with this, we have to discretize the continuous model and to get a discrete time state space model, and that can be applied to a physical controller. Now talking about an important thing that is the observer, the state feedback with observer. Well, we have that. It is an estimator. It's a system that provides an estimate of the internal state of a given real system, any real system. And that is taken from the measurements of the input and the output of the same system. So how do we design this? Well, here is the MATLAB code to show you. So first we have to get the plant, an RX model plant in this case, that we did in evidence 1. And that will give us the plant that we can use to design our controller, our state feedback controller in discrete time. So once we have done that, once we have chosen the best model, the best RX model we got from evidence 1, we have to define the matrices of the state space. So you have 5 here, gamma, C, and D. With that done, we can start placing our poles to get the response that we desire. In this case, I chose these poles, 0.1 minus I 0.5 and 0.1 plus I 0.5. As you can see, they're complex conjugated poles. You use the place function and you get the state feedback. And for the observer, you only need to multiply the poles of the controller of state space feedback by 2, and squaring the poles, and you get the observer. And then you also use the occur or place function depending, and you get your observer. Once you have that, well, we have our model. And as you can see here, the bandwidth of this controller, this system is much larger than 5 radians per second. So it accomplishes the points that are asked. And well, actually by far it's a very good controller in that case, that specific thing. And as we see the step response, well, we can see we have a set time that is much lower than 2 seconds. And as you can see here, it can be seen that it's a very aggressive controller. But we have to try first in the Simulink model to see if that is actually working correctly. So here we have the original model, and now our controller with the observer. Once we execute the simulation, we get this graph that is the the relative phase, and we can see here that yes, the controller is very aggressive, but we can see that it works. So now here the thing to consider is which are the capabilities of the actuators we will be using. Because if we use an extremely aggressive controller and our actuators are not capable of giving that response, we can fail to control, or we can also damage the actuators. So we have to design based on the characteristics of the actuators we have. So finally, about what I've learned in this course, well, I think I have a very good theory about what makes a good controller and how it's designed. What are the things that you have to consider as you design a controller? The different type of controllers that can be designed, the lead compensator, the PID controller, the state space, the observer. And I think that I have a very good general knowledge about it. Although I think I can learn a lot more and improve a lot more. But in general, I think this course was very useful. I think I learned a lot, and I think that I like about this is that now I have my own. I have already committed myself to learn more by myself because I think I really liked what I have learned, and I see the value that this has, and I think it would be worth it to get a lot of knowledge from control systems. And I think that was it. Thank you for your attention.